Shut up and sit down.
In this video, we're going to talk about Python lists. They're an incredibly useful data type that I use all the time to keep track of data as you're calculating things, as you're recording things. And once you get them down, I think you'll find that they're incredibly useful for your work as well. So let's get right into this. We're going to start with a set of slides, a little overview of Python lists, and then we will get into the code to give you some hands-on examples with these data types. Okay, so what is a list? And this comes about when you need to store or save many numbers, but you don't want to declare many variables. So imagine you wanted to store information for all the grades in a class. You don't want to have like grade 1 equals 90, grade 2 equals 50, grade 3 equals 98, and so on and so on. And what you'd like to do is you'd like to keep them all in one place. And what you'd like to do is you'd like to keep them all in one place. That is, have like one variable called grades that keeps track of all your numbers. So I sometimes think of them as like an egg carton, and you're putting all of the different values or your eggs that you're putting into the egg carton. I don't know why this is a 10 egg carton, but it is. And sometimes you might want to keep many numbers and words all in one place, and we'll show an example of that. And this image that I have is where you could have yellow and purple and blue and pink and green, all sorts of different types of values, or in this case, Easter eggs inside your container. Lists are probably part of a broader class of data types called containers, for those of you that may continue on in CS or to more advanced data science topics. So let's think about just a list that you would keep normally. Forget about Python, forget about programming. A list, and then eventually we'll find out arrays, is very similar to just a shopping list, if you will. So here's a little shopping list I have, and you're making it, here's what I need to buy. Number 1, I need to buy coffee. Number 2, I need to buy creamer. Number 3, Cheerios, dish soap, pasta, sausage, paper towels. This number right here, 1, 2, 3, 4, 5, that tells you where the information is located, whether it's the first place, second place, third place. This is called the index. And you're going to hear me using the word index throughout this lecture. What the information is the value that is stored in that index. So again, we use a list to hold information or keep track of stuff. That's what you'll be doing with your computer code. What the information is called the value, and then the number that tells you where it is in the list is called the index. And eventually, when we get into NumPy arrays, this same idea holds. So let's go over this in more detail. Let's suppose I have a Python list here, and I've recorded the numbers in it, 1, 2, 3, 4. These are the values. These are what the information is. But the index for Python and many other programming languages starts at 0. So this index telling you where it is, this is in the 0th place. This will be in the 1 place. I'm not using the first because this is actually the first, even though the index is 0. But this is in the 1 location, the 2 location, and 3 location. And I'm trying to emphasize the difference. These numbers here, 1, 2, 3, 4, are the values that are stored there. And what we'll find is that we can store numbers and characters equally well. So the way I would write this in Python is I would have my variable x, and I would use square brackets here, 1, 2, 3, 4. And this representation here, this Python code is what I have represented here. So this is a list. I could also have strings of numbers, strings of characters. So instead of the integer 1, the integer 2, and the integer 3, notice I have these little quotes around them, meaning that this is a string, and I've stored 1, 2, 3, 4. I would write this out as x equals square bracket, 1, 2, 3, 4. I still have the commas separating each one of these words, and they're still stored at index 0, 1, 2, 3. With lists, which is very different from Python arrays, as well as other containers and many containers in other languages, I can mix strings, integers, and floats. So I could have one, the word one. I could have an integer 2. I could have the word 3, and then I could have a float 4, and that would be represented as 1, O-N-E in quotes, 2, 3 in quotes, 4. I can also add on to the end of my list. I could add on with a function called append, which just goes to the very end and appends whatever number we want. So once I've declared my array, I have this member function dot append, and then in parentheses, I put the number in, and now I have a new index here for 4. If I want to access the elements of the array, let's suppose I just want to print the first entry, I would use index 0 in square brackets. So I have x, and then in square brackets 0, and that gets me whatever is stored at index 0. If I do x3 in the square brackets, I'll get whatever's in index 3, so 0, 1, 2, 3, and that's the value 4, and it would print 4 to the screen. So again, I'm going to use this terminology index or indices, which is the plural of index, throughout the rest of this lecture. Let's go ahead and try it. Okay, so let me read some of the text that I have here. It just reiterates what we said. Lists are holders for data. This is a live link here that has a different, somewhere else on the web, there's another kind of little tutorial about lists. You can go there and check it out if you want. And this is very useful when you want to keep a lot of similar or not so similar data together just in one variable. And lists are a data type, just like floats, ints, or strings. And if you use the type function, you'll see that it returns something called list. And you can read a lot more about the built-in functions. This is a live link that'll take you to the official documentation. I encourage you to just click on it just to see all the things you can do with lists that are built in that you don't have to write any extra code for. So let's start using this. We don't have to import any modules. This is all built into Python. We're going to make a list called mylist, and then we're going to fill it with at least 5 words. We're going to make sure that they're separated by commas, and then we'll print the list to see what we see. Now, let me give you a warning that applies not just to lists, but to other variable names. Never name your list list. And if you do that, you're going to wind up overwriting that command in Python. What it means, Python won't really know how to do lists anymore. Similarly, you should never name your variable print, int, float, or so on. And if you do, what you want to do is you want to go up to runtime and then reset the runtime. Okay, so let's go ahead and make a list called mylist. So I'll do mylist, and I'm going to fill it with 5 words. So I'm going to do an open bracket, and notice that Colab has Jupyter Notebook has kindly filled in the closed bracket here. So let's do this. You can use your own words if you want. I'll do twas brillig and the, oops, forgot my quotes, the slithy toves. I won't worry about typing out, what is it? Twas brillig and the slithy toves did gyre and gimble in the wabe, all mimsy with the borogroves and the mome rats outgrabe. This is from the Jabberwocky. This is from the Jabberwocky, is that how you pronounce it? From Through the Looking Glass. Okay, so here's my list. And if I want to, I can now print my list. These are in parentheses. First time I do it, it takes a little longer. I'm just starting up the notebook, and notice when it prints it all out with these square brackets around it. Okay, so again, we're going to keep doing this. Twas brillig and the slithy toves. It's the first line from the Jabberwocky. So let's go ahead and print the first word in the list using the index of 0. And again, this is important to remember that when you're actually trying to access stuff, that your indices start counting at 0. So I'm going to print my list, and we've already declared it just to remind you what it is. And then I'm going to print my list 0. So I get the original list here, and then I get the first entry. Notice I don't have, the quotes around it anymore. This is just a word, just a string. And I get the first line, or so the first word. And then you could also go, just to show you a little bit more, you could go to the third entry if you wanted. So my list, if I wanted the third entry, first, second, third, 0, 1, 2, the third entry would be with my list 2. Make a little quote here to access the, what did I say, third entry. And 1, 2, 3. And you could also, if you want to, assign the second entry to a variable. I could do x equals my list. The second entry would be index 1. And if I print that, I get Brillig. So 'twas Brillig. Okay. You can also go right to the last element of a list. So instead of going 0, 1, 2, 3, 4, maybe you don't know how long it is, you can get to the last element with -1. So if I wanted to, I'm going to print my list, just to remind ourselves what we have here. And then I'm going to print my list -1. So it's Brillig and the slithy Toves. Toves is the last entry. -1 went to the last one. And how do you think you can get to the next to last element of the list? Well, -1 gets us to the kind of last one here. Next to last, print my list. And for those of you that may have guessed, you're correct. My list -2, so that goes back to Toves and then slithy. Okay. With these indices, you can also pull out subsets and slices of it. So suppose I want to print just the second and third elements of a list. So we would use index 1 and 2. You can also think of this as going from 1 to 3 minus 1. And you're like, well, Dr. Bellis, why would you want to do 3 minus 1? And that's because the notation that we'll use, so if you have a list called X, if you have n colon m, it gives the elements from n up to m minus 1. So we'll keep using my list, print my list here. And if I do print my list, and I'm going to do 1 colon 3, it's going to start at 1. And then it's going to go all the way up to and print everything that is before 3. So it stops just before it gets to 3. So 'twas Brillig and the slithy Toves. 1 to 3 means start at the 1 index. So 0, 1 is Brillig. 2, and then it stops just before it gets to 3. And you will wind up making use of this, this slicing syntax in order to get subsets of the data. You could also do n colon, and that'll give you the elements from n all the way to the end. So print our my list, the whole thing. And then if I want to get from index 3 to the end, I can just do 3 colon 0, 1, 2, 3. So I get the slithy Toves, and I haven't specified anything at the end, so it keeps going. If we have colon m, that will give us the elements from the beginning to m minus 1. So I'll do print my list here. And then I'll do print my list, and then I won't have anything to start. I'll have colon, and then I'll have 3. So this should give me 0, 1, and 2. Stop just before the 3. 'Twas Brillig and the slithy Toves, 0, 1, 2. 'Twas Brillig and is what we get. Now, we can assign any of these subsets to a new variable. So let's go ahead and grab a subset of my list and assign it to something called my subset. So print my list, and then what I'll do is subset equals my list, and then let's have 2 colon 5. So this will go 2, 3, 4, and then it'll stop just before 5. Oops. Then I'll print subset. And I get twas brillig and the slithy toves. That's our my list. And then the subset starts at 2, 0, 1, 2, and the slithy 2, 3, 4 stops just before 5. And that's how you would extract a subset, or it's also called slicing the list. Now, lists can be a little bit tricky to use. We're going to talk about this idea of mutable. So mutable means changeable. So what we're going to do is we're going to define a list and set another variable equal to that list, but we're going to find that there are pitfalls with that. So once we've done that here, we're going to print the lists, then change the element of the original list and print the lists again. So let me show you what I mean by that. Let's have one list A, and let's fill it with 0, 1, 2, 3. And then I'll close that. So I'm just using integers here. I'm not using words. And then I'm going to set B equal to A. Now I'm going to print A. And then on the new line, I'll print B. And you will not be surprised that they are the same. So now we're going to change the first elements of the original lists and print them again. So first I'm going to make a little blank line. And then I'm going to change an element of the first list. So I'm going to go to A0. And instead of printing it, I'm actually going to set it to a different value. I'm going to set it equal to 999. And now when I print A and I print B, you might think that I'll get 999, 1, 2, 3, 999, 1, 2, 3. But in fact, 999, 1, 2, 3, and then 0, 1, 2, 3. What we find is that by changing the element of the first list, it automatically changes an element of the second list that we assign to be equal to each other. Now, this is very different than if we used floats or integers. If I changed one value for a float and then set it equal to something and then changed it again, the one that I assigned it to wouldn't change. So that was kind of confusing. Let me give you an example right here. So let me create a new entry. You might want to do the same thing. So try this with floats. So let's do x equals 10, y equals x, print x and y, and we get 10 and 10. Oops. Print another blank line. Now, if I say that x equals 20 and I print x and y again, y has maintained the value that it originally was. So x was 10, y is equal to x. What this did is it actually assigned the value of 10 to y. So when I change x, y doesn't change. That's very different than what happened up here. Here I said 0, 1, 2, 3, b equals a, and when I changed the value of a, it changed the value in b. So this is the idea of lists being mutable or changeable based on how they're assigned to one another. And there are ways to prevent this from happening if you don't want it to. Okay. As I mentioned in the lecture, you can make a list that is a mix of strings, floats, and integers. And you might think, well, why do you want to do that? And suppose you wanted to make a list that has a first name, last name, age, and height. So you're trying to record some information about people. So let's call this person 1, and that's equal to, let's say it's my name, Matt Bellis. My age, at least when I'm typing this, though it'll change over time, is 51. So now I have an integer, and let's record my height. So I'm 5'7". Let's just do 5 times 12.0 for inches plus 7. Then I don't have to worry about doing that calculation, but it should come up to 67 inches, I think. And if I print person 1, Matt Bellis, these are strings, integer, and float. And I want to emphasize that if I print the type person1, I get that this is a list. Now we're going to make a list of a different person, and we're going to put both of those lists into one list and print that list of lists. So what do I mean by that? Well, let's suppose I have person2. And let's say that this is someone else. Let's say this is LeBron James. Apologies to the haters out there. How old? I should know this. How old is he? Let's pause for a second and I'll go look this up. Okay, so when I'm typing up this code, LeBron James, as of today, is 36 years old, and his height is 6'8". And so again, rather than me doing this in my head, I'll do 6 times 12.0 to make sure we get a float, plus 8, so that should be 72. That should be 80 inches. We'll print that just to see that we got this second person correct. Okay. And now we're going to add this to a list of lists. And why would you want to do that? Well, suppose you're just keeping track of a bunch of people. And I can make this equal to person1, person2. And if I print that people, and I'll add a print statement here just to give us a little space. I'll see I get LeBron James on the first one, but look at this. Now I've printed in the first entry, it's a whole list here with all that information about me. And in the second entry here, we have all this information about LeBron James. So let's check ourselves. Let's see if we understand what we did there. You can see right here, this list of lists kind of acts like a two-dimensional array, which means we're going to need 2 indices to reference those parts of the cell. So first, let's print the second element, that's index 1 of the combined lists. So what we're going to do is we're going to print people in square brackets 1. I'll make a little, I'll get ahead of myself and print a little blank line there. So I print people 1, and I get the second element of the combined lists, which itself is a list. Now I want to print the second element of the second element. So this right here is the second element of the main list. And then 0, 1, James, we should be able to pull out by accessing 1 of that. So what we need to do is we need to print people 1. And then to get the index, the second element in that, we need another square bracket 1. And then I pull out James there. And of course, I could, like, if I wanted to, I could access other elements. I could set them equal to variables. So I could say I've got a variable named age, and that's equal to people 1, the second entry there, or sorry, the 2 index, which is the third entry. And I would pull out the age, 0, 1, 2. Okay. You may want to add to your lists. I do this all the time. So let's go ahead and create an empty list. Then we'll fill it. We're going to make an empty list named grades, and we're going to fill it using the append function. And then we'll print it to see what we got. So I'll make empty list grades, open square brackets, open close square brackets. And then I'll use the append function, grades.append. Let's suppose someone got a 90 on that one. Grades.append 89, grades.append 95, grades.append 87, grades.append, let's say 92, and so on. And then if I print this, I started with an empty list, but I added 5 values to it. So I don't have to declare it all at once with everything right off the bat. And many times you'll just be doing calculations and storing what you did. Now you can add a list to a list using either the plus or the plus equals function, and this is very useful. It doesn't actually add the values together within the lists, but it sticks the 2 lists together. So I could do this if I wanted to. I could take grades and I could do plus equals. Let's suppose I've got a bunch of other grades I have to record to put into it. 95, 88, and so on. And do that. I could also, if I wanted to, make other grades. And then maybe there's a bunch of other grades that I've got to record, 88, 98, 96, and so on. And then I could have total grades of everybody equals grades plus other grades. Now I've got everybody all together. When I run this again, it's actually going to add this one more time because I'm running the cell. So you'll see these four numbers appear twice because I've run this cell twice. So I get all of these. There's our 186, 95, 88, 186, 95, 88. And then I added these other grades into it. There's many other functions within these within the list data type, and you can access them if you have something. Let's say I've got, what did I call this up here? Grades. So if I do grades and I hit dot or period, like I was going to call a member function, now you can't see it, but I'm hitting the tab key. I get all of these different things. I can append, that's what we were just using, but you could clear it. You could make a copy, you could count, you could extend it, get the index. If you put some value in there, it would find what index it is, and so on and so on. And that is very useful. There is, of course, the documentation that I mentioned you can link to for the official Python documentation. You can find that link at the top. So again, the way I got there was I typed grades, I typed period as if I was going to do some other member function like append, and then I hit the tab key, and this will like auto-complete, or I can find out more information about it. So if I type clear, I could go back to the beginning and do a question mark, and now if I hit Control Enter or Shift Enter, I get all this information on the side. Remove all items from list. And if you want to get rid of that, you just X that out. And I will put a hashtag in front just to comment that out. Now, sometimes you want to create lists of numbers. You don't want to type them all in, but you're going to find yourself using these lists of numbers all the time very soon. So there's a function that's built into Python. We don't need to import anything. It's called range. So it gives you a range of numbers. And if I just use it like range m, it's going to create numbers from 0 to m minus 1. Now, when you first call it, it doesn't actually do anything. This is a change from Python 2, but now that you're using Python 3, you'll find that this creates actually a function that can iterate over numbers, but it doesn't do anything at first on its own. But we're going to wind up using it in a loop a lot. But if you want a list of the numbers, you just use list, and then in parentheses, you put this range m. So let me show you what I mean. If I want a bunch of numbers from 0 up to 9, I can do x equals list, and then I'll do range, and I'll do 10 because the range function stops just before it gets to that number. And if I print x, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, these are all integers. Just to demonstrate to you what the data types are. So I'll do print type x, that's the type of the list, but if I do type x of, and then in square brackets 0, that should give us the type of the first entry, which is an integer. Range can also start you off at a value other than 0. So if you do range n to m, it'll start at m, and again, it goes up to m minus 1. So if I do x equals range, and I do 5 comma 10, it will start at 5, and it will go up to just before 10, and so it'll go from 5 up to 10. Now, if you on its own, it doesn't actually do anything. What it says it'll do is it'll count them. If I want that into a list of numbers, I have to have the list around it. When we start doing loops, we're going to find out that we do not need this list around it, but this is just to demonstrate that if you actually wanted this list for some reason, 5, 6, 7, 8, 9, it stops just before 10. You can just take your range function and use list with open close parentheses around it. If you want to go in steps of other numbers, so let's say in steps of 2 or 3 or 4, you can do range from n to m. It'll go from n up to m minus 1, but in steps of I. So if I do x equals, now I'll just put it in the list, range, and then I'll, let's say, go from 10 up to, and I'll go to 101, so I get up to 100, and I'll go in steps of 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm actually getting to 100 this time because I said stop just before 101. And just to emphasize what each of these are, maybe I should have a different number here. I go from 10 up to 100 in steps of 5. So this 5 is telling you what this last number tells you, the steps to go from one to the other. Now, sometimes after you've collected a bunch of data, you need to know the length or the size of your list, and there's a built-in function to Python. Again, we don't need to import anything that gives you the length, and you just type len, which is short for length. So I can just print the len of x like we just did up there. Or what you find yourself doing sometimes is you assign the value. So you might have n grades, which is the number of your grades, and that'll be the length of your total grades, which we typed earlier. And then if I print n grades to the screen, we'll see that we had 17 grades in total. Okay, so that's an overview of lists. We'll be using them a lot throughout the rest of the semester. Hope this was useful for you. Bye.